Hello students, welcome to today's session. And in this session I'm taking a named reaction called Hoffmann Bromamide degradation reaction with its mechanism. Okay, let us start first with a reaction. In Hoffmann Bromamide degradation reaction, we start with an amide and we convert an amide into a primary amine. So it's a method of conversion of amide to amine, or we can take in other words like it's a method of preparation of primary amines. The reagent used in this reaction is, we can take first one, bromine in aqueous or ethanolic solution of sodium hydroxide. So what happens here, when amide is treated with bromine in an aqueous solution or ethanolic solution of sodium hydroxide, it is converted into a primary amine, and the primary amine obtained is having one carbon less compared to the starting amide. So you got many times a question asked based on this reaction, like guess the amine obtained by taking a particular amide. So one point to be remembered here, amide, and you can take the obtained amine is having one carbon less compared to the starting amide. Okay, so at first I take a reaction given as per NCERT. Okay, the reaction given as RCONH2, this is amide, upon treatment with bromine in sodium hydroxide, it can be taken as aqueous or alcoholic solution, results in the formation of RNH2, this is primary amine. Along with that we'll get some byproducts, they are sodium carbonate, sodium bromide and water. Right, this is NCERT equation given. Now let us take another equation which is helpful in guessing the intermediate obtained in this reaction. Right, so we can write another form, the same reaction, RCONH2, that's amide, upon treatment with bromine and sodium hydroxide, it forms isocyanate. Right, this is very important. So we'll get formation of intermediate as isocyanate, that can be written as R N double bond C double bond O. Once you get isocyanate formed, the next step is hydrolysis. So hydrolysis of isocyanate will form primary amine, and the carbon here lost in the form of carbon dioxide. Right, so in this way we can convert amide into amine. This is about the reaction, and remember the intermediate obtained in this reaction is isocyanate. Okay, so I taken one more term here, it's also called Hoffmann rearrangement reaction. Okay, I'll explain while taking its mechanism. Let us take its mechanism now. Right, first one, the first step now I have taken starting with amide RCONH2. As we're having sodium hydroxide, it produces OH minus. So what it does now, OH minus will abstract a proton. So this proton is getting abstracted by OH minus. As it abstracts a proton, the bonding electron here between N and H will shift between carbon and nitrogen. You can see here, right, this arrow mark. Bonding electron will shift between carbon and nitrogen. So if it shifts between carbon and nitrogen, this carbon becomes pentavalent, right? Okay, so one bond should be broken, and which bond is going to break here? The weakest bond, and that should be the pi bond, right? Okay, the pi bond breaks, and it will shift on the oxygen in the form of lone pair of electrons. Okay, so you can see the change now. What you get, the species look like this, in which oxygen is having negative charge here, right? We got a negative charge, then we got C double bond N, right? So you got formed here C double bond N, and one hydrogen is lost, okay, which is abstracted by OH minus. So you got formation of an anion now. Next step is, this oxygen is having 3 lone pair of electrons, right, on this 3 lone pair of electrons. So one lone pair will again shift, right, to form a bond between carbon and oxygen. So this again becomes a double bond. You can see here, right, you got a double bond. Okay, as it becomes double bond, carbon again becomes pentavalent. Okay, this carbon becomes pentavalent, and one bond again should be broken, right? And what happens now? This bond or bonding electrons will form or can take help in bond formation between nitrogen and bromine. In the second step we take what? Reaction with bromine natural. Okay, so what happens here? Nitrogen bromine bond formation takes place. Okay, so what happens then? Structure look like R C double bond O. Okay, you got R C double bond O. Then this double bond became single bond right here. Okay, this became single bond. Then NH, new bond formation takes place, right, between nitrogen and bromine. Right, so you got formation of this product. Now you can take like halogen substituted amide, right? Okay, the next step is again reaction with the base OH minus. Now what it does, OH minus, again we got one acidic hydrogen here, right? So OH minus will pick this hydrogen, and if it picks this hydrogen, the bonding electrons you can see here, right, I shown arrow, will shift between carbon and nitrogen. And again what happens? Carbon becomes pentavalent, right, this carbon. And if it becomes pentavalent, and again the bonding electron will shift on the oxygen in the form of lone pair of electrons. Just see the structure obtained here now. The structure look like this, right? R C, then this become what? O minus. Then I got double bond formed here. N, one hydrogen lost, right, in the form of proton, and then bromine. Okay, so we'll get again anion formed. Right, the next step is very, very important here. You can see oxygen again having three lone pair of electrons, right? This oxygen. What happens? One lone pair again shift to form a bond between carbon and oxygen. So if you write double bond here between carbon and oxygen, you can see the valency of carbon is becoming 5. So what happens then? Again one bond should be broken. So what happens here? Alkyl along with the bonding electrons will shift to the nitrogen. Okay, so if alkyl shift to the nitrogen, we can take this as a rearrangement reaction, right? Because one of the alkyl is shifting from carbon to the nitrogen. So remember, this is a migration of alkyl from carbon to nitrogen. Okay, now just see how it look like. The species obtained here, R will attack on the nitrogen, right? And as a result, this bromine is eliminated in the form of bromide. So we can write what now? R, first starting with R, right? I have taken here R, then it forms bond with N, so I have taken N, right? Then double bond C, double bond O, and this species or intermediate we can call it as isocyanate. Now once you get isocyanate, the next step I said already, right, it is hydrolysis reaction now. Okay, so I take an isocyanate here. What happens? Hydrolysis you can take because we are having NaOH also, right? Basic medium. So OH minus first will attack on the carbon because this is having more electrophilic nature, right? It attacks on the carbon, and as a result, what happens? The bonding electrons here will shift on the nitrogen. Okay, N becomes N minus. Okay, if N becomes N minus, what it does? Instantaneously it picks a proton because we got aqueous medium, right? H2O present, so instantaneously it picks a proton. We can see here, right? On nitrogen we got one hydrogen here. Okay, and this becomes what? One OH is attacking on the carbon, so as shown here, this is a hydroxy. Okay, right, next step is what now? Again OH minus will pick acidic proton. We got again one acidic proton here which is attached to the oxygen, right? Okay, OH minus will pick a proton. The bonding electrons shift here between carbon and oxygen, so it just becomes double bond. Then what happens further? Carbon becomes pentavalent, so the bond, one bond should be broken here, right? And to get more stable products, what happens? Carbon nitrogen bond is going to be broken here, and the bonding electrons will shift on the nitrogen. So again N becomes N minus. As you know, it is unstable, right? So what happens? Instantaneously it picks a proton and converted into RNH2. Along with that, we'll get a stable byproduct, carbon dioxide. Right, so in this way we take conversion of amide into primary amine by using Hoffmann Bromamide degradation reaction. Okay, and remember the intermediate involved in this reaction or rearrangement reaction is isocyanate. And which type of rearrangement reaction is this? Means it is of the type like migration of alkyl from carbon to nitrogen. Okay, so in this way we can take mechanism for Hoffmann bromamide degradation reaction. If you like the video, please subscribe to my channel. Thank you.